So this is the question that's been on my mind for the past month now. It's just been in my room and it's been taunting me. So basically, I tried to use logarithms, but it didn't um, amount to anything. I'm gonna just resort to using a genetic algorithm, a new concept that I've been learning for around like a day now, to I guess brute force this equation to find the best approximate x value. All right, let's do this.
The random module is imported to generate random numbers for the initialization, the selection, and the mutation processes in the genetic algorithm. And this is the function that we're trying to optimize. And the reason why I wrote -5 instead of =5 is because I wanted the function to be close, like the function, the f of x, to be close to 0 as possible. And this is where where I define the fitness function. So the fitness function basically like evaluates how good the solution x is, and if x is equal to 0, the if f of x is equal to 0, the solution will be considered as perfect, and it will return the score of 9,999. And if it's not, then the value of x will go through this thing, which will generate a fitness score. And this is where we initialize the population. So it basically generates an initial population of 1,000 random solutions in the range -10 and 10. And each of these solutions could be x. I think that's a good solution. I think that's a good explanation for that line. And this is the loop, and it basically just goes through like 10,000 generations of solutions. And you might be wondering like, if this isn't this just going to come up with the same results for each generation? And this brings us to the next line of code. And so this line of code basically evaluates the fitness of each solution, and this line basically appends the ranked solutions tuple. What this means is that the program is just sorting the solution and its fitness score together in the ranked solutions list. And this is where the program sorts the list out, and it basically reverses the list from ascending order. So basically, the highest fitness comes first. Yeah. And yeah, so this basically prints out the best solution of the current generation, and this is the position of the, and I guess I guess this is the position of the best solution of the generation. Yeah. And this is the convergence check, which basically is there to check if the fitness level, if the best solution of the current generation's fitness score is greater than the threshold of 999, and which will break the algorithm, which will stop the algorithm early. And this is here to select the top 100 solutions, the highest meaning the highest fitness score as parents for the next generation. And this extracts the solution, not the fitness score, from the top 100 solutions. And this whole big chunk is to create a new generation of a thousand solutions, and this means that the algorithm picks the top performing this thing it basically picks the top performing elements, I think, top performing solutions, and it's called parents. It's basically called parents, and it's used to create new solutions for the next generation. And this applies a random mutation from the range 0.99 to 1.01. It basically just gives a slight mutation to these selected random factor, yeah, something like that. and this puts the mutated solutions into a new gen tuple, and this line basically replaces the old solutions with the new generation mutated solutions, yeah, something like that. So basically what you do is that so it basically came up with the best solution in 2 generations, which is actually pretty impressive. So the fitness value for this is 4,461, and this is the solution. Apparently this is the solution. So